Hello students, welcome to our lesson today. Today we are starting on Form 3 work and we are going to look at the chapter 2 of Form 3 chemistry, that is the mole or the mole concept. So we are going to introduce the mole. So we start by looking at the definition of mole, and we say that the mole is the unit of measure of amount of a substance. So we are saying the mole is a unit of measure of a substance. So in chemistry, how do we use mole or how do we define mole? So in chemistry, we define mole as the amount of any substance that contains Avogadro's number of particles. So that is the definition of mole. The symbol for mole is MOL, that is mole, and a mole represents a fixed number of items written in significant figures as 6.023 times 10 raised to the power 23. So that is the Avogadro's number. So that number is called the Avogadro's constant, and it is represented by the letter L, and therefore 1 mole is equals to the Avogadro's constant that we are calling L, and it is equal to 6.023 times 10 raised to the power 23. A mole is used to measure the amount of particles, or it is used to measure the amount of particles. These particles are, for example, the atoms, the molecules, the ions, the electrons, and the compounds. We have come across all these terms, and these are what we are referring to as particles in this topic. So I'm going to define these terms, and I'm going to start with the term atom. As Anya defined, an atom is the smallest particle of an element. You can see it is a particle. So it is the smallest particle of an element that can take part in a chemical reaction. That is an atom. We are talking of particles, and we have seen that it is the smallest particle of an element that take part in a chemical reaction. Then we look at the electron. What is an electron? It is a negatively charged particle. So you can see also an electron is a particle. So it is a negatively charged particle. The other particle we are going to look at is an ion. So we defined ion as a charged particle formed when atoms gain or lose electrons. So an ion is a charged particle. It can be positively charged or negatively charged. So it is a charged particle formed when atoms gain or lose electrons. Yes, so then we look at the other particle, or the other term is molecules. The molecule is the smallest particle of a substance. So we are talking of particles, the smallest particle of a substance that has all the physical and chemical properties of that substance. And when we talk about molecules, we talk about a substance that is made up of 2 or more atoms. So those are molecules. So we are going to look at these particles, and these are what we are going to use as our particles that we are going to look at in the concept of the mole. So we are going to come across this term, the molar mass, and we define molar mass as the mass in grams of 1 mole of a substance. So molar mass is the mass in grams of 1 mole of a substance. Then when we are talking about molar mass, we are talking about three terms, that is the RAM, RMM, and RFM. So these are just the initials, and we start by the relative atomic mass, or what we call the RAM. This one we have seen it previously. So relative atomic mass, we talk about it when we are dealing with elements. Elements are, for example, we have hydrogen, carbon, sodium, calcium, potassium. All those are elements. We saw them, we can name them, all the 20 elements in the periodic table that we looked at in Form 2. So we deal with relative atomic mass when we are referring to elements. Then relative molecular mass, we use the relative molecular mass, or what is abbreviated as RMM, when we are talking about molecules. Examples of molecules are, for example, oxygen molecule, nitrogen molecule, chlorine molecules. So all these are molecules. You can see it contains two atoms, and that is what we referred to as a molecule. The third one is the relative formula mass, or what is abbreviated as RFM, and this one is used for compounds. Compounds are, for example, sodium carbonate, water, potassium sulfate, potassium carbonate. All those are compounds, and we deal with relative formula mass when we are talking about the compounds. Now, here's something we should note. We have an NB here. We should note that 1 mole is equals to 6.023 times 10 raised to the power 23 particles, and it is the same as the molar mass. So this molar mass can be replaced by the RAM, RMM, or the RFM. So 1 mole of a substance is equals to 6.023 times 10 raised to the power 23 particles of that substance is equals to its molar mass. So this one we are going to apply for in the coming examples. So we look at each one of them. We start with the relative atomic mass, or the RAM. We say an element has mass equal to the relative atomic mass. We have seen that an element is equal, its relative atomic mass is equal to its mass, or its molar mass. So an element has mass equal to relative atomic mass in grams. So the mass of that element is equal to its relative atomic mass. So for example, if we are talking about carbon, the molar mass of carbon is equal to its relative atomic mass. So if the molar mass of carbon is 12.0 grams, it means the relative atomic mass is 12.0 grams. So that is what we mean. Then, for example, for sodium, the molar mass for sodium is 23.0 grams. So what is its relative atomic mass? It is also 23.0 grams. So 6.023 particles of sodium is equals to 1 mole of the sodium element, and is equals to 23.0 grams. So the molar mass is equals to the relative atomic mass, and is equal to 1 mole, which is equal to 6.023 times 10 raised to the power 23, what we call the Avogadro's constant. The second one is the relative molecular mass. We said from the molecular word here, we are talking about a molecule, and a molecule also has a mass equal to the relative molecular mass. So in grams, the relative atomic mass, how do we get the relative atomic mass? We get the relative atomic mass by getting the sum, or finding the sum of the relative atomic masses of the elements making that molecule. So if we have two elements, so we get the relative atomic masses of each element, then we get the sum, and that's what gives us the relative molecular mass. Then the number of atoms making a molecule is called the atomicity. And most gaseous molecules are diatomic. For example, oxygen molecule, hydrogen molecules, those are made of two elements or two atoms. That is why we call them diatomic. If it is for ozone, is made up of 3 atoms, we call it triatomic. Helium is made up of 1 atom, we call it monoatomic. So for example, if we consider the oxygen molecule, we have the relative molecular mass of oxygen molecule. We know that the relative atomic mass the relative atomic mass of oxygen is 16.0 grams. So that is for one mole or one atom of oxygen. So one atom of oxygen is 16.0 grams. But now here we have a molecule which consists of 2 atoms. So if we want to get the relative atomic mass of the 2 atoms, we shall multiply 16 by 2. So 16.0 times 2 will give us 32.0 grams. So the relative molecular mass of oxygen molecule will be 32.0 grams. So we say 6.023 times 10 raised to power 23. This is constant. It isn't changing. Particles of oxygen molecule will be equals to 1 mole, which is equivalent to 32.0 grams. Let us look at chlorine molecule. So one chlorine atom has a mass of 35.5 grams. But now here we are talking about a molecule. Chlorine molecule has 2 chlorine atoms. So to get the relative molecular mass, we shall take the relative atomic masses of the 2 chlorine atoms and then we get the sum. So this will be 35.5 plus the other chlorine atom, 35.5 grams, which would give us 71.0 grams. And then we say 6.023 times 10 raised to the power 23 particles of chlorine molecule is equal to 1 mole, which is equivalent to its mass or equivalent to its molecular mass, which is 71.0 grams. Similar to the nitrogen molecules, nitrogen has a mass of 14. So nitrogen atom has 14.0 grams as its mass, so times 2 to make it 28, which is similar to 1 mole, and it's also equivalent to 6.023 times 10 raised to the power 23 particles of the nitrogen molecule. So that is relative molecular mass. Then we have the relative formula mass, or what we are calling the RFM. We deal with relative formula mass. We said we deal with that when we talk about compounds, and we said a compound has a mass equal to the relative formula mass. This is from our NB up there. So we are still comparing the relative atomic mass, the relative formula mass, the relative molecular mass to the molar mass, or to the mass of that molecule, to that compound, or to that element. So a compound has a mass equal to the relative formula mass in grams of the molecule. Relative formula mass, how do we get, or how do we calculate the relative formula mass? By taking the sum of the atomic masses of the elements making that compound. Okay, let us look at a compound like water. So water is made up of hydrogen, 2 atoms of hydrogen and 1 atom of oxygen. So we are going to take the atomic mass of hydrogen, 2 hydrogens, and that of oxygen atom, then add to get the relative formula mass of water. So the relative atomic mass of hydrogen is 1, multiplied by 2 to give us 2, then plus that of oxygen is 16, so 16 plus 2 to give us 18 grams. So 18.0 grams of 18.0 grams of water, the grams that gives us the relative formula mass. So we are talking about the relative formula mass, or the mass of water molecule being equal to 1 mole of the molecule and is equals to 6.023 times 10 raised to the power 23 particles of water molecule. Then these 6.023 particles of water molecule, it contains 2 times 6.023 times 10 raised to the power 23 particles of hydrogen atoms. So note that if we want to get the atoms of hydrogen in water molecule, we are going to multiply 2 times 6.023 times 10 raised to the power 23. Then oxygen is 1 atom. So we are going to multiply 1 multiplied by 6.023 times 10 raised to the power 23 to get the particles of oxygen atoms. I hope that one is clear. Then we have another example of sulfuric 6 acid. The formula is hydrogen, 2 hydrogens, and SO4. So the relative formula mass, we multiply or we add, we get the sum of the masses or the atomic masses of hydrogen, 2 hydrogen, 1 sulfur, which is 32, and 4 oxygen atoms. So when we add all this, we get 98.0 grams. So 6.023 times 10 raised to the power 23 particles of sulfuric 6 acid contains 1 mole of 98.0 grams. So that is the relative formula mass. Then in this 6.023 times 10 raised to the power 23 particles of sulfuric acid, we can get the hydrogen atoms by getting the number of hydrogen atoms here, that is 2, then multiplying it by 6.023 times 10 raised to the power 23. If we want to get the particles of sulfur atoms, we take the number of sulfur atoms here is 1, so we multiply 1 times 6.023 times 10 raised to the power 23, and similar for oxygen, it is 4 multiplied by the same. I hope you are still following, and now with this last example here, we can now fully understand what is going on. So if you want to look at sodium carbonate, this is its formula. We have 2 sodium, carbon, and 3 oxygen atoms. So its relative formula mass, we add the masses of the 3 atoms. So we have 23 times 2 plus 12 plus 16 times 3 will give us 106 grams. So 6.023 times 10 raised to the power 23 particles of sodium carbonate is equal to 1 mole and is equal to 106.0 grams. That is the relative formula mass. In these 6.023 times 10 raised to the power 23 particles, we have sodium atoms as the number of sodium atoms are 2. We multiply by the constant here, 6.023 times 10 raised to the power 23. The same to carbon and the same to oxygen. So that is how we calculate the atoms present in that compound. Okay, so let's look at the practice questions here. And we start with the first question. That is, we calculate the number of moles present in 0.23 grams of sodium atom. So here we are calculating the number of moles. So what we know is that 1 mole of sodium atom has a mass of 23 grams. So now we are being asked what the 0.23 grams, what is the number of moles. So we are going to write our 0.23 grams down there. So how many moles? So what we need to do is just cross multiply here. So we shall have 1 multiplied by 0.23 grams divided by 0.2 divided by 23 grams. So this one will be 0.23 divided by 23, which is giving us 0.01 moles. Look at that of chlorine. So we are calculating the number of moles present in 0.23 grams of chlorine atom. So as we know, 1 mole of chlorine atom is equals to 35.5 grams. So now what about 0.23? 0.23 grams. How many moles? So same to what we did up here, we cross multiply. So we shall have 1 times 0.23 grams divided by 35.5 grams. So this is 0.23 divided by 35.5, which is giving us 0.0065 moles. So these are the number of moles present in 0.23 grams of chlorine atoms. Roman 3. Now here we are calculating the number of moles present in 0.23 grams of chlorine molecule. So note now, it's not the atom, we are dealing with the molecule. So 1 chlorine molecule is equals to, or just chlorine molecule is equals to 2 chlorine atoms, and the mass of 1 chlorine atom is 35.5 grams. So now if they are 2, we have to multiply this one by 2. So 35.5 multiplied by 2 will give us 71.0 grams. Now here we can compare 1 mole of chlorine molecule will give us a mass of 71.0 grams. So what about 0.23 grams of the chlorine molecule? So again we cross multiply here. So this one will be 1 multiplied by 0.23, then we divide by 71.0 grams. So this is 0.23 divided by 71.0, which should give us 0.0032 moles. So that is the difference between the chlorine molecule and the chlorine atom. Then finally here we look at sulfuric acid. So 0.23 grams of dilute sulfuric 6 acid. So the number of moles. So here we start by finding the relative formula mass of dilute sulfuric 6 acid. Its formula is H2SO4. So to calculate the relative formula mass here, we said is we get the sum of the atomic masses of the atoms present. So here we are going to have hydrogen, its molar mass is 1 multiplied by 2. Then we add that of sulfur, that is 32. Then we have 4 oxygen atoms, so this is 16 multiplied by 4. So the total here in grams will give us 98.0 grams. So 1 mole of sulfuric 6 acid gives us 98.0 grams. So what about 0.23? So again we cross multiply here. So we are going to have 1 multiplied by 0.23, then divided by 98.0 grams. So this one is giving us 0.002347 moles. So you can look at what is happening when we are calculating the number of moles. The first one, we have divided the the mass of sodium atom divided by its molar mass, or its relative atomic mass. So it is mass over the molar mass. Then again for chlorine, we have also divided the mass over the molar mass. That of dilute sulfuric acid, we have calculated its RFM. Then we have finally divided here the mass of the sulfuric acid divided by the molar mass, or the relative formula mass of dilute sulfuric acid, which is 98.0 grams. So what we can deduce here, when we are calculating moles, what is happening is that we are taking the mass, then we are dividing by the molar mass. So this is the formula of calculating moles. So if you want to get the number of moles present in an atom or a molecule or a compound, we take its mass divided by the molar mass. And now from this formula, we can also get mass. So to calculate mass, we are going to take moles now times the molar mass. So moles multiplied by molar mass. If you want to get the molar mass, we just interchange. So molar mass is equals to mass over the number of moles. So this is what we can deduce from that. So question number 2, we are calculating the number of atoms present in 0.23 grams of dilute sulfuric 6 acid. So the number of atoms. So we are given the Avogadro's constant as 6.023 times 10 raised to the power 23. So what we need to get first here is the relative formula mass of dilute sulfuric acid. And to get the relative formula mass, we take the atomic masses of all the atoms present in sulfuric acid. So we have hydrogen, these are 2, so 1 multiplied by 2 plus 32 plus 6 multiplied by 4. We have 4 oxygen atoms, so multiplied by 4, and this one is giving us 98.0 grams. So how many, if 1 mole of dilute sulfuric 6 acid has a mass of 98.0 grams, what about 0.23 grams? So 0.23 grams, so grams and grams. How many moles? So what is the number of moles in 0.23 grams of dilute sulfuric 6 acid? So here we cross multiply. So this is 1 multiplied by 0.23, then divided by 98.0 grams. So this is giving us 0.00237 moles. So previously from our notes, we saw that 6.023 multiplied by 10 raised to 23 of the particles of sulfuric 6 acid is similar to 1 mole. So what about the number of moles here that are present in 0.23 grams? So what about 0.00237 moles? Now, when we are referring to the number of particles here, we are finding the atoms. We said atoms are one of the particles. So we can also say 6.023 times 10 raised to power 23 atoms of sulfuric 6 acid is equals to 1 mole. So how many particles are there in 0.002347? So we cross multiply here. So this one will be 6.023 multiplied by 10 raised to power 23 multiplied by 0.00237, and this one gives us 1.38 multiplied by 10 raised to power 21 atoms. So those are the number of atoms present in 0.23 grams of dilute sulfuric 6 acid. Okay, Roman 2, we are finding the number of atoms present in 0.23 grams of sodium carbonate decahydrate. So we need first to get the formula of sodium carbonate decahydrate. So we have sodium carbonate, that is sodium carbonate. Then decahydrate means 10 molecules of water. So that is the formula of sodium carbonate decahydrate. So let us get the relative formula mass. So this is 2 sodium atoms. So we have 23 multiplied by 2. Then plus carbon has a mass of 14. Then we have 3 atoms of oxygen, so multiplied by 16, plus we have hydrogen is 10 multiplied by 2, that is 20, then multiplied by 1, so that is water, then plus 10 atoms of oxygen, that is 10 multiplied by 16. So all this is giving us 288 grams. So this is the relative formula mass of sodium carbonate decahydrate is equals to, so 1 mole of sodium carbonate decahydrate has molar mass of 288 grams. So what about 0.23 grams? So what about 0.23 grams? How many moles? So again, cross multiply here. 1 multiplied by 0.23, then divided by 288, and this one will give us 7.9861 times 10 raised to power negative 4 moles. So we want the number of atoms present. So we know 6.023 multiplied by 10 raised to power 23 is equals to 1 mole. This is atoms, or the number of particles of sodium carbonate decahydrate is equals to 1 mole. So what about 7.9861 multiplied by 10 raised to power negative 4? We are finding now the number of atoms. So we cross multiply here. So we are going to have 6.023 times 10 raised to power 23 multiplied by 7.9861 multiplied by 10 raised to the power negative 4, and this one gives us 4.81 multiplied by 10 raised to the power 20, and these are the number of atoms of sodium carbonate decahydrate. So number 3, we are calculating the mass of 3.0115 times 10 raised to the power 23 atoms of aluminium, and in brackets here we have the molar mass of aluminium as 27 grams. So to calculate the mass of this one, we first start from what we know, 6.023 times 10 raised to the power 23 atoms of aluminium is equals to its molar mass, which is 27 grams. So we are being asked, what about 3.0115 times 10 raised to the power 23 atoms? So we are to calculate the mass. So what we need to do is cross multiply here. So you are going to have 3.0115 times 10 raised to the power 23 multiplied by 27. Then this we divide by 6.023 times 10 raised to the power 23. So this gives us the mass as 13.5 grams. So that is how we calculate the mass given the number of atoms. Question number 4. How many atoms are there in 1 mole of oxygen molecule? So 1 mole of oxygen atom has 6.023 times 10 raised to the power 23. So this is oxygen atom. But for oxygen molecule, we have 2 oxygen atoms. So to get the number of moles in oxygen molecule, we multiply 6.023 times 10 raised to the power 23 multiplied by 2. So this is giving us 1.2046 times 10 raised to the power 24. So those are the number of atoms in 1 mole of oxygen molecule. Finally, we look at question number 5. How many atoms are there in 2 moles of bromine molecule? So 1 mole of bromine molecule will be 6.023 multiplied by 10 raised to the power 23. That is 1 bromine atom, then multiplied by 2. So this will give us 1.2046 multiplied by 10 raised to the power 24 atoms. So this is equivalent to 1 mole, but here we are being asked about 2 moles. So if 1 mole is equals to 1.2046 times 10 raised to the power 24, what about 2 moles? So again here we cross multiply, so this will be 1.2046 times 10 raised to the power 24 multiplied by 2. So this simply gives us 2.4092 times 10 raised to the power 24 atoms. So those are the examples we are having for today, and we continue to look at more examples on questions related to the mole in our next lesson.